Kamal, I think we can start now. Hello?
All right, so we can start.
Thank you.
Let's go for screen sharing.
We would like to see your face this morning before you start.
Oh, sorry, I did not enable my video. Sorry for that. Okay, better now.
Uh, Hello,
Sure.
Camille.
It sure is. Yes,
Uh,
hello.
this is Emmanuel.
Oh yeah.
Before we start, I can see Helen she's connected. She's one of the she's the representative of the funder from INRIA.
Okay.
So she may just want to pass some comments or give us
Okay.
some remarks. Helen, good morning.
Good morning. Yes,
Yeah.
I am just here for the beginning to see how it is working today, and I see that everything is going well. So I'm quite happy with that. I will not stay with you later, unfortunately. But so just to say, everybody, welcome, and for this new day, and also for our speaker and teacher, actually. Thank you very much, and have a good day and a good session today.
Okay, thank you. And we are all greeting you
Thank you,
from here.
Ellen.
Okay, thanks. So over
All right,
to
so we are
Camille.
ready to start. Okay, so for today, we're gonna go back to storage, to a few concepts that had been viewed yesterday, but unfortunately I had no time to prepare all the diagrams. So yesterday evening I translated my current diagram and updated them, especially for the few bit complex parts regarding the storage and the RAID mode and data center. So if you don't mind, we'll first go to that, and then we'll go back on the initial program. But I think it was important that we make a short back to this concept. Let me check the data center part. It's okay. So okay, we can go ahead. So yesterday, one of you asked me for more explanation, and I agree. It deserves to give you a few more explanation about how it is important to consider at the very low level um, the power and cooling. Well, cooling seems obvious, since without proper cooling, whatever the solution, water cooling or air cooling, you will get very soon in trouble if you have not an appropriate dissipation mean for all this energy which is dissipated by servers and so on. But the power is one of the most important consideration part of cooling. So I'd like to, I don't know, can you see my cursor now? Hello, can you hear me? Well,
We can
I
hear
don't
you.
know. Maybe if facilitator
We can hear
can
you.
confirm. Yeah, and can you see my cursor?
No?
Ah, yes, it's going to be a problem. Well, okay. If you cannot say it's not, we'll try to be a bit more precise. So what we can see here. I did not make any cinematic to explain, but the idea, what I wanted to illustrate in this case, regarding what we said yesterday, is that it is very important to consider power redundancy. And here, what I try to represent here is a typical data center setup. So we have racks, any number of racks that are dual powered, that are secured by UPS, as you can see. So each UPS is powering as a power supplier redundant, and the power distribution unit on each rack also are often doubled. So what we used to do is to provide this uninterruptible power supply, this inverter, which are generally big ones, not not the one I represented. Generally, it's at least the size of one rack, and the equivalent in terms of battery. And the purpose of that is not to provide a power backup for the whole power outage duration. Indeed, it must be seen as a kind of buffer, power buffer that can handle for, let's say, depending of your total consumption power and depending of your battery capacity and depending of your UPS also, it can provide from 30 seconds to 15 minutes backup, which will be the time needed to power up your generator. So it means, yes.
Excuse me to interrupt you, but I guess you are assuming that we are seeing your screen, right? Because we don't only see you. We see your face, but not your screen.
Oh, I don't know why it has not been shared. I'm sorry for that. Okay, let me arrange. Well, it was working well yesterday.
Yes, it's okay now. Great.
You can see better now. I'm sorry for that. If you had not been sure, it has not a lot of interest. Okay, maybe you can confirm, yes, that you can see my cursor. If I move my cursor here,
yes, we see your cursor.
Yeah, you can see. Oh, okay, that's brilliant. Okay. Yeah, sorry. So as you can see here, we have these racks represented, whatever the number. The idea is that you can see that they are using redundant power, and that's why we said yesterday any spuff must be eliminated. So we don't like a single point of failure, and we want to, I mean, your goal as a system architect, designer, whatever level you are, is to eliminate every spuff you can. So the single point of failure can be found at a lot of level, at almost each level in an information system. But at the very basic, when it comes to power and cooling is basically everything for a data center. So without power, you will get nothing. So that is why it is important to consider this power redundancy and make sure it is correctly set up, because we already saw some cases where we have two independent power distribution unit. I mean, two independent per rack, but that had been cable wired on the same live wire, on the same power line, I mean, or it can be on two different power lines, but using the same UPS, which is a basic design error. So here, if you can see my picture, it's a kind of you can make an analogy maybe for the ones that are already familiar with storage or network. We often used to call that a multipass. But in terms of power, it's more something, say, redundant power or whatever. What is important to understand is if you consider to secure your data center, especially in Africa, where the power is known to be not stable in terms of voltage, frequency, also in terms of harmonics that are leading to short equipment lives, especially power supply. That's why it is very, very important to consider your power supply quality and your power quality in general. That being said, I would like to emphasize again regarding the UPS choice. This is not something you want to unconsider. I mean, the price should be put on such important things as UPS, since it's not only protecting you against a power outage, but a well-designed UPS. I mean, what we call an online UPS, which is recreating a pure sine wave, is very important, and it makes a difference. So that being said, as you can see here in the picture, you have the main power, main AC power that come from, according to the data center size, you can have your own transformer that can transform very high voltage to low voltage. I mean, to 240 volts. And this can be also redundant. So generally, it's advised to have a dual power source at the beginning of your data center, or have your own transformer. And on top of that, the very common setup is to have on top of this dual UPS, to have diesel generator, or generally redundant also, but at least one power generator. So when the UPS will be used, when the power outage will occur, the UPS will just act as a buffer. So as said previously, it is not meant to last for the whole power outage duration. Not at all, because if you want to do that, you would need to have a gigantic battery park and gigantic UPS, and it is not something which we can, which you can handle. So keep in mind that an UPS in a data center is really meant as a power buffer, and that's it. So I would, as Per said, I would say between a few seconds to a few minutes, but that's it. Do not expect more from a UPS with such power. For a Sequana rack, to give you an idea, with it's 1 kilowatt per blade, so 96 kilowatts per rack. If you have a few racks, I let you imagine how much the power is big on. It's a big challenge to store that. So the idea is to have this UPS as a buffer, and the UPS to trigger the diesel generator to start as soon as possible, generally 1 or 2 minutes. So the generator take over the UPS and provide the power directly to the node. So this is how it works and how it is generally designed. So I just so you know, I did not have time to make proper explanation, but the orange link are DC power coming from the battery Generally, it's 48 volts, sometimes 96 DC voltage. Diesel generator and main AC power have been represented in gray, since we are considering that as dirty power. I mean, it's a power with not stable frequency, not stable voltage, and loaded generally with a lot of harmonic, and often have a power factor not compliant, I mean, not desirable for such equipment. So for all these reasons, a performant UPS, and I would say definitely an online interactive UPS, which in fact is internally never puts a load in front of the main AC. So even when you are in nominal working, you are never directly coupled with AC. So even in nominal condition, okay. I mean, even in standard nominal condition, the load is never in front of either the generator or the AC power. So the UPS also acts as a filter. It will convert the AC power to DC, and from DC it will reinvert it to recreate a proper pure sine wave current. Yeah.
Yeah, please, there is a question.
Yeah, sure.
Okay.
Go ahead.
Good day, Mr. Campbell. Please, the UPS, you've mentioned UPS. Will you prefer me to make use of UPS or inverter in my data center? Which one will you prefer me to use? Because if you are using UPS is quite expensive to inverter. UPS will only take 50 minutes, just as you have said, 50 minutes to hold me before I put on my generator, while inverter here in Nigeria, inverter can assist you for a longer time while on solar charger.
Well, it's a good question. Just so you know, what we call a UPS is a generic term. UPS is basically an inverter with battery. That's it. I don't know if it answers your question, or maybe I didn't understand what you are calling an inverter. But basically, an inverter is something that can provide sinusoidal current from DC current. It is basically, it's for those familiar with electronics, it's kind of a H-bridge, something what you call an H-bridge, which is used for PWM, for instance, or for any kind of modulation. But this is typically a big H-bridge using MOSFET, and this is what it is, and what is an inverter, technically speaking. UPS is just an inverter on which you put a battery, a battery set. That's it. So, so I guess I didn't understand maybe your questions, or we are not using the same terms. Can you please come again to explain me the difference you make with what you call an inverter and UPS?
Mr. Campbell, I said since you've said UPS and inverter are the same thing. The difference is the MOSFETs, the battery size, and the MOSFETs. Just changing those.
No, sorry. No, MOSFET are generic components that is used for generating for making AC current. So both all inverter are using MOSFET. Yeah. So what I mean, well, in my terminology, UPS is the world system. Inverter is just what is what is generating the AC current.
Okay. Okay. So you
UPS is,
mean
for me, it's basically the battery, inverter, and transformer. Transformer to elevate current mounted as an elevator. So it takes in entry, it will take something like, let's say, okay, 12 volts AC, and it will elevate it to 240.
okay? Thank you very much.
You're very welcome. But I'd be interested to, if you want to discuss later on offline, if you have other question in this regard, because I'd be interested to know the difference for you between inverter and UPS. For me, UPS is a set of battery plus inverter, or maybe you are mentioning a generator. Yeah, go ahead, please.
Camille, I would
Yes.
like you to illustrate if it exists, because here in Africa we can take advantage of energy from the sun, solar. Can you illustrate, like you just did now, the illustration of the power backup here has the alternate of the generator and the UPS. Are there scenarios that already exist, maybe apart that we
Yeah.
can take advantage of here, maybe the solar,
Um,
how it can be
yeah,
connected to, if you
there
have
has been.
any of such, can you
Mhm.
illustrate it for us to see?
Quickly here, it will be a bit hard for me, but I can tell you I saw a few example of good use of mixed energy. Um, this is something we can also discuss offline if you're interested to, since it's a separate subject. But to answer your question, yeah, I saw, especially on the field that was in Central Africa, but it applies the same in Nigeria. The thing is, when it comes to solar power, you have a few consideration in the battery technology, the same that are going for a normal UPS actually. When it comes to battery, um, well, I would say you have two big families. You have gel battery, the one we call AGM, mm, which are leaded, jellified lead, and are the most used for solar power or for UPS in general, since they are not requiring any maintenance and so on. The thing is, those ones are not very performant. To give you a rough idea, you have to consider about at least twice or 2.5 the capacity you want to power. You have to provision at least, yeah, I would say 2.5 in if you go for AGM battery uh, times of the power you want to sustain. You know what I mean?
Okay.
And on top of that, the durability is not. I mean, the cycles the battery can sustain of charge, discharge, etc., is not extraordinary. So my advice, just to make a short answer, is I would say yes, it's possible, but if you consider the right battery technology. And I would say for that you want to go for lithium or lithium for what we call LiPo. LiPo is definitely the only solution ISO2 works correctly for very high load. And this is the only one that can sustain for sure for at least 8-10 years without being needed to be
Replaced.
recycled. Hmm. Yeah. I hope it answers your question.
Yeah, thank you.
Mhm.
Thank you very much, Camille. I think you can share your slides again.
Okay. All right. Okay. Let me take it back. Sorry. I agree. Power consideration is a big one for data center in general, and especially in your particular context. I know well what you are meaning. Not only in Nigeria, I mean, I don't know lots of African countries, even in South Africa, they have big problem with power. So this is definitely something which can be, I would say, a kind of blocking point for a lot of initiative. And I would say the only thing for now on a short term or middle term is to rely on your own setup, guys. Don't rely on on power company, and that's for sure. So unless you are a big industrial and you have the means to have your own transformer and so on, and even in this case, you will be subject to a lot of power outage. So this is definitely where you want to put your money first when you design that, just to also to save your investment also. Okay, I think we can switch straight back to storage if you are okay. Or maybe, sorry, I didn't ask. Is there any other questions you would like to ask regarding data center, or not especially related to power, but anything you want me to go back? Maybe PMC or
Any questions, please? I think no questions, Camille. We can move ahead.
all right. Okay. So just so you know, as uh, the time has been very short for me. I would like to dedicate all this morning to all we have to see on, I would say, the hardware side. It's a bit quick because you will see hardware tomorrow with my colleague Tom, but it is going to be something much more oriented to build products. So my goal also here is to provide you with a consistent set of information and tips and tricks and advices regarding hardware in general, and something very practically oriented. Okay, so I suggest that we switch straight back to Red, since I felt that yesterday there was a lot of questions going on regarding that, and if you want, we can talk also about other storage technologies, especially SAN and NAS, if some of you are interested. But for now, we'll go for a quick flashback to Red Technologies, and just so for you guys, it will be very clear, and you can make your choice when it will come to make a decision. Okay, so I made a few diagrams to, I hope it will be a bit more clear on how RAID is working and why and how we use it. So we're going to start with RAID 1, okay, like yesterday, and then RAID 0, and then RAID 5 and 6, and maybe RAID 1 plus 0, but I think you will understand very clearly now. So RAID 1, what was the purpose? The idea was to be fault tolerant. So as a reminder, always keep in mind that despite you are using RAID 1, it doesn't mean you will be protected about ransomware, about human error, about any bullshit that can happen, and I mean, because of a human action. Any loss of data due to a file system corruption or so on. RAID 1 is not meant to protect you against that. It is meant to protect you from a physical disk failure. Okay, so here in this diagram, I tried to represent you. I hope it will be clear. how a file is written to a logical unit number, I mean to a read volume, let's say, and how it is seen. Here we have two physical disks. Let's say there are maybe 100 gig. So here, the LAN I would see that will be exposed to my operating system, to my machine, is going to be 100 gig. I mean, you will see one virtual device that will be sit on top of two devices, two physical devices. So when I will attempt to read ABCDGEFGH, it will be written in real time on both devices, on both physical devices. So the benefit of that is, if we look at the second table, if something is going wrong, if physical disk number 2 is burnt, is failed, or has whatever problem, the data will still be readable from the remaining member. The other benefit is that you will, in a nominal situation, if I go to table 1, in read mode, you will get a benefit. The more member you will put in your read 1 array, the more read performance you will get, since the read can be distributed. Here I represented a write, but if we were going to read, it would relate to the same, except that we can read from both member 1 and member 2 simultaneously, and then we'll improve throughput. I mean, how much data will be transferred, and also what we call I/O, input output. This is something fundamental. I/O, we like to have a lot of I/O capacity, and storage SSD are excellent for that, and RAID arrays also are often an answer to get a large amount of I/O per second. Or when we say I/O, it's input output, and it's often referenced as IOPS, input output per second. This is one of the metrics that qualify a storage. Let's say we have three main things when we talk about storage. We have volumetry, we have throughput, I mean read throughput and write throughput. What are the performance, disk bandwidth, and the IOPS. So what are the performances for raw input output? How much read and how much write orders the device can handle. And typically, a device that suffers, especially when it comes to I/O, if it suffers of a lack of I/O, it will stack your read request or the write request. So it's going to be stuck and queued at the disk controller, and then it will stack and stack and stack again. And at the end, it will penalize your processor, since it will generate a lot of IRQ, of interruption request on the hardware. And this is something our processors don't like, because when an IRQ occurs, I think everything knows that an IRQ is an interruption request. This is the only thing that can stop a processor from doing something. So the more IRQ you have, the more processor interruption you have, and when you have a lot of IRQ that are stacking or queuing in a bottlenecks, such as badly designed storage or slow storage or whatever problem, it is something very painful, and it gives a very bad experience to your users. We can take other example of that. Yesterday we discussed about NFS. If you want to have an idea of what is a stable system, just try to mount an NFS and break the link. You will see how the client will appear as to be stale. There is a lot of reason for that. There is circumvent for that, but always bear in mind that if for some reason, even if you are using NFS or direct attach or whatever, but if your storage is going wrong, you will feel it on the processor very quickly and on the whole machine. Even if it's not a storage used by your system, if it's just a scratch volume or a temp or whatever, but storage must be well considered. Okay, so maybe you have questions in regard of RAID 1? Any
Are there
questions
any
here?
questions?
That's fine, brilliant. So
I
just
think
keep
we
in
can
mind
go
also
on.
something. Yes, go ahead.
I think we can go on.
Oh, we can go on. Okay, just a last word regarding RAID. I represented with 2 members since it's a strict minimum, but indeed you can have as much member as your controller permits. And also regarding RAID, we'll talk that a bit later at the end of that sequence. You have software and hardware RAID, and the choice must be carefully done. And for most of the case, I would, generally speaking, recommend software RAID if you know what you're doing. It's software RAID is definitely a good choice. And I would add to that if you have to go to software RAID, I would recommend to use RAID over LVM. What we call LVM, maybe we'll talk that a bit later in the Linux section, but LVM is definitely something you want to consider when you want to do software RAID. It's much more easier and flexible to use RAID over LVM rather than to use raw software RAID, which is a bit more complex and there's a few pitfalls and drawbacks. So generally speaking, if you want to go for software RAID, prefer RAID over LVM. It's always easier to manage. And the last thing, indeed, yesterday we talked about FreeNAS and TrueNAS. This is really a brilliant way to make a low-cost, very performant storage. If you design correctly your underlying hardware, you can have a first-class storage system just with TrueNAS. And on top of that, TrueNAS, despite of its name, is also able to provide SAN facility using HPC at least. I don't know for fiber channel maybe, but at least I know it can provide HPC functionality, so you can get SAN for peanuts for nuts. Okay, ladies and gentlemen, we're gonna switch to RAID 0 now. So RAID 0, as we explained yesterday, is a different strategy. It has not been designed to provide any kind of redundancy. It has been designed at the beginning to provide or to go beyond a few physical limits of hard disk. While we have other setup, we have also another mode that we call JBOD, but I strictly don't advise you to go to JBOD unless you have a very good reason. But generally speaking, you won't use JBOD. JBOD stands for just a bunch of disk, and it's a kind of a RAID 0 but without striping. It means that it will expose a continuous disk, continuous LAN, which is made of a few physical disks, and it will write on the first disk. When the first disk is failed, it will go to the next one, etc., etc. This is JBOD. So RAID 0 has been meant to be a kind of JBOD with improvements that is using stripes and striping technique, which is completely different than mirroring, which is used by RAID 1. RAID 0 provide a bigger logical unit, Or for instance, here, if we have two physical disks that are 100 gig, you will see here a logical unit, which will be a 200 gigabyte disk. This virtual disk, this LUN, the right name is LUN, but you can say virtual disk or VG or whatever, but this is typically a LUN. So this logical disk, especially if you are using a hardware RAID controller, your operating system has absolutely no way to see that it is a RAID underlying. So how it is working here, if we are writing the string A, B, C, D, E, F, G, H on the logical unit number, you will see that it will be striped into two different chunks. One will be written on disk 1 and another one will be written on disk number 2, resulting in a dramatical performance improvement in both read and write compared to mirroring, which was just improving read. In RAID 0, I would say basically once more, the much you put, the more you put member on it, the more it is fast. So you can say it's almost multiplied performance are almost multiplied times the number of disks. So I would say, for instance, if you have a throughput of let's say 100 megabyte on a hard disk, using a RAID 0 with 2 member of such a hard disk, you can expect almost 200 megabyte of throughput. Also, the I/O are strictly improved. So you have a lot of benefit to go for RAID 0 when you have no concern about your data. So typically, a stateless machine such as a compute node or any stateless machine, or it can be also just for a given volume. You are not forced to put your whole machine to sit it on RAID 0. You can just create a few volume using RAID 0, other using RAID 5, other using RAID 1, depending of your need. But typically, if you want to improve easily your performances, your I/O, and globally your throughput in case of a scratch directory, for instance, or a temporary directory, RAID 0 is definitely a good choice. Yeah? But you have to bear in mind that, as you can see on the second figure, if by ever you are losing a member, you're losing everything. Okay, so A, B, C, D, E, F, G, H won't be reconstructed. I cannot be reconstructed, so it's going to be lost. E, F, G, H is on the defective disk, and it's going to be lost. That's it. That's why, as per CDS today, it's even easier with SSD now, but even with traditional hard disk, you can always recover your data if you have the money for. If your data worth the money, you can always recover them. Not by yourself, however. But I would not wish you to fall in such a case, since data recovery for hard disk is something expensive. Data recovery for enterprise class hard disk is even more expensive, and data recovery coming from a RAID array is even more expensive. So I wish you won't fall in such a case. So let me check for the time. Oh, it's already 11 here. Give me 1 second, please. Okay. Maybe if you're okay, we can continue with the storage and come back after on servers. And so we postpone the break to a bit later, if you don't mind. So I'm gonna switch now, unless maybe you have questions about Red Zero. Any questions? Any remarks?
Or remark?
Okay, fine.
None.
Fine. Okay, we're gonna switch to Red 5. So Red 5, I agree it was a bit hard to explain it yesterday without a proper schematic. So here we go. We have still one learn. This time we are using a Red 5 array, and we are attempting to write the string you can see here. Yeah.
Yeah. After you're done with this session, we can go on break.
Okay, you would. It's up to you. What time is it? 11 on my. It's 10 for you. I'm
Yeah, it's
trying to
10.
check about. Okay, so it's finished for this session, right?
Please come again.
Yeah. Okay. No. I realize that you're right. We already finished this session. Normally, you are in break at this time, right?
We can continue till 10:30 or
Okay. Now,
11:35.
okay, what I suggest in this case, okay, let me check it. So, 11. Because of the offset, it's not easy for me to organize. Okay, well, if you want to go, guys, if you want to go in break, go ahead. And after that, we finish with storage. Maybe we go back to servers. And after, if you don't mind, you will go in lunch break. So it it will save me some time to prepare the next diagram, because
Okay.
yeah, I think it will be better this way.
We have some time
Hmm?
till 10:30, so we can continue till 10:30.
It's up to you guys.
11:30 for you. Yeah.
Okay, so we push till 11:30 for me. Okay, so 22 minutes, fine. Okay, all right.
Yeah.
Okay, fine for me. Let me share again. Okay, can you see my screen again?
Yes.
Hello? Okay, so you can see my screen back. All right. So for Red 5, it's a bit different strategy, as you can see. In Red 5, we are aiming to combine both best of two worlds, I would say, both striping and not mirroring, because it's not mirroring, but we are taking parts of advantage, sorry, of the parity. So I don't know if you guys remember what I tried to introduce yesterday in regards of the logical XOR, exclusive OR, which is a basic algorithm used by Red Zero to make its stripes. So Red 5 is working, I would say, very similarly. Unless the difference it's compared to Red 0, it's that the stripe is not only a data stripe on as compared to what you just see before, but also when the algorithm is dividing a stripe, it will calculate a data parity. Okay, so for instance, when it will attempt to write the first block of data, it will stripe A, B, C, D and store the parity on the first available disk. And then for the next block, it will go the same, but this time it will shift the parity to another disk. This is why it is called distributed parity. And the good things with RAID 5 is you've got the benefit of the RAID 0. It means that if you look at the schematic, or well, I took 4 disks since it's almost a strict minimum to use on RAID 5, but it means that you are making the best use of the 2 previous technologies, I would say, because if you consider RAID 1, you lose a lot of capacity. You have to determine capacity of a RAID 1, you have to take the wall capacity added divided by the number of members. So it's very poor. Okay, for 8 disks you get 1 disk, for 2 disks you get 1 disk, and that's it. In RAID 0, you have not this problem. You get 2 disks, you have the size virtual disk, which is equivalent to the sum of the 2 disks. But in RAID 5, it's almost like that. But as you will probably guess, if you count the parity, you will see that at the end you lose 1 disk. So if you plan to design a RAID 5 storage, you will have to bear in mind that your final capacity will be the result of your voltage set minus 1. Okay. And indeed, using RAID 6, it's minus 2. Okay, because if you add at the end, if you add all the parity, you will get exactly the size of 1 physical disk. So it means that, for instance, if one wants to have a, let's say, a 300 gig RAID 5 array, and this guy will consider to purchase 4 physical disk. So to get the capacity, the total capacity of 3 on the virtual device, on the RAID 5 LAN. Okay, so this is, I would say, a bit fundamental concepts when it comes to storage. You have to, RAID will be your best friend, I guess, RAID and LVM. And moreover, I would like to surround the fact that the paradigm has evolved since 15, 20 years ago, where I would have maybe recommend you, okay, guys, go for a hardware controller, or hardware RAID controller for now, and for a lot of reasons, but mainly I would say, okay, go for a RAID controller if you can prove that you have some spare, and you can prove that you can rebuild your RAID array, not only by losing a disk, because this is normal in an array life, but if you lose the RAID controller itself. If you burn your motherboard, if you burn your RAID controller, make sure before purchasing or doing this choice that you are able to recover from a lost RAID controller. Make sure that you are able to recover your data. If you are not sure of that, and you cannot prove or you cannot afford to have sufficient spare, I would not advise you go for hardware RAID. And that being said, a few years ago, hardware RAID was preferred because of its simplicity, and you don't have to do nothing on the OS side. It is totally transparent. I agree with that, and also because it was using an hardware XOR engine. It means that the parity calculation striping is calculated by dedicated ASIC, dedicated processor DSP embedded on the storage controller card. This is fine, but actually with the current power we can get on even the cheapest server, software RAID implemented in the Linux kernel is brilliant in terms of performance. It can go beyond the performance of some hardware RAID controllers, with the benefit of the price and with the drawback of I would say the need to master, because it's very easy if I drop you a few command line of if you use any assistant to set up a RAID array in software, you won't struggle to do that. It's pretty easy. But I would say as I tried to surround yesterday, you are in trouble if you're exploiting something or responsible of something that you want to manage, even storage array or can be a network or whatever, and you are in trouble if it is working and you cannot explain why, because it means that the days at the first issue, at the first occurrence of a failure or whatever, you will be basically lost, and you will be basically almost stuck, and it is most likely going to be the day when the problem will occur. It will be most likely a good occasion for you to make a mistake, because you won't be familiar with what is running on your installation. So I would advise, well, it's the same for everything, I would say, but especially for software RAID, it's not very complicated, but it's worth to take time to understand how it works and how to implement it, how to monitor your RAID array. And same goes for hardware anyway. If you have a hardware controller with RAID, that's fine. You are protected, but you need to install at least management for this RAID controller and a proper SNMP trap or any alerting, any way to be made aware that, okay, guys, our disk is failing. So I think you know now. Any questions, any remark in regard of this RAID?
Thank you, Kami. And I was asking, like, here in this picture, we don't see the difference between parities.
Oh, sorry. Yeah, I would have. I agree. You're right. Actually, I would have to precise that. Okay, this parity is the one from ABC. This parity is DEF parity. This parity is GHI. Is it more clear for you? This is a very good question, remark, I mean.
Yeah, but
so the parity is okay. The stripes must be read this way.
Okay, so the parity is
as a row.
Backup of one of the disks, maybe.
Not the backup. It's a parity.
No, it's not the backup.
It's a checksum. Well, yeah, you can say that like that. Okay. Let's say, okay, you break a disk. You will find when you will replace, let's say, okay, you break disk number 4, okay, for the first stripe, okay, A, B, C are present, so you have just nothing to do. For the second stripe, D, E, and only parity are present because F is not anymore because this number 4 is fried, right? So in any case, even you have nothing to do, if you let's say let's consider the first row. So here you have nothing to do. Second stripe, you will have to calculate parity, calculate F with D and E and parity, and then okay, and then for the next row, you will gonna have to calculate the missing I with by using G plus H plus parity. So yes, you can say, okay, if you want, you can say it's a backup, but it's not a backup. That's a parity. That's it. I cannot say otherwise.
Okay.
Yeah.
I got it.
But yeah, consider it as a backup. At the end, you're right. Huh? At the end, you're right. It can be seen as a backup. Yeah, sure. It just actually you have to put yourself at the place of the RAID controller that will reconstruct the missing hard disk. If you are the RAID controller, okay, you said that detects that for the smart system embedded in disk will ensure predictive failure, okay, and then a failure. So you will remove the member from the array, and the array will be called as a degraded mode. It means that it's not failed, but it is degraded. So it means that it cannot afford another failure. So one physical disk number 4 will die, and indeed you will send someone to replace it, etc., etc. This is important also. This is very important. We talked about that yesterday. I cannot say how many times I saw disaster. I had to make recovery because of clients that didn't replace the right drive. That is stupid. I agree. Especially when you go for with a big storage with 200 or 300 disk in a storage bay, in a storage island, it is very easy to be fault. So that's why you guys must be very comfortable with your management tools, especially when it comes to storage, because it doesn't tolerate to make a mistake, at least not on RAID 5. And it's very, very common to have a customer to replace the wrong disk because of a lack of identification. So this is something you want to check very closely. And as we said, so when you will have sent someone to replace the disk, etc., etc., the first thing that or depending how your RAID is configured and hardware and software, you can configure to rebuild automatically or not. But generally also something I didn't talk about is a notion of spare and hot spare. When we are, everyone knows what is spare, but spare can be cold spare. It means that, this is a drive you are storing with someone in a secure storage when you put your spare parts, okay? And you can also, in both hardware and software RAID, you can have what we call a hot spare, which means that this disk will be alive but not used, and will be assigned dynamically by the RAID controller or by the kernel if you are using software RAID, and then this disk will be taken over or will be assigned dynamically to replace defective disk. And depending of your strategy, you can ask your RAID controller to automatically reconstruct the array against this hot spare, or just to wait for you to say, okay, go ahead to reconstruct it. So you have different strategy. But once more, it's a good practice to have hot spare, and it in sometimes in some cases, sorry, it can avoid some mistakes. But it won't replace, even having hot spare, it won't replace a good knowledge of your storage, a good knowledge of how to administer and locate, especially locate your physical device in a RAID array. That's a bit fundamental. Mhm. Well, I think that's it for. If some of you want to go to red, what we call red 10, but it's not very interesting to mention it. I didn't have time to make a diagram for this one, but just imagine it. Red 10 is a combination of red 1 and red 0. It means that you can see it as here. It's like if you have a red 0 under each physical disk. Okay, so the benefit of a red 1 plus 0 is very poor, but it is sometimes good in some configuration, but I don't think you will see it. You will see this case. It is sometimes required in some very specific cases, but it's not something very common, and especially it's not efficient at all in terms of capacity of a lost disk, because you understand that if you are attempting to do a RAID 10, you will use at least 4 disks. And to get to 4 disks, you will get the capacity of 2 disks. So it's almost equivalent to RAID 1 in terms of usable capacity at the end. The only thing is that you improve drastically the performance in read and write because of the underlying RAID 0. So each RAID 1 target is actually a RAID 0 under the hood. And so the cool thing is that well, the only cool thing with that is you improve both read and write performances while being secured and mirrored. But once again, it's just not really useful. It's always better to go to RAID 5, definitely. RAID 5, RAID 6. Just last word about RAID 6. I don't know if I said it or not, but if you are using RAID 6, you are using double parity and on 2 different disks indeed, which means that your total capacity will be the total number of disks additional minus 2, minus equivalent capacity of 2 disks. So this is important to consider to know. I don't think there is much more to say in regard of RAID, unless you have some particular question, remarks, or you want to know something else.
Hello.
Yes.
Just one question.
Yes, sure.
I want to know, for example, if the physical disk number 4 is loose, is the replication will be done automatically or not?
No.
If we replace.
In the current, if you replace it, it depends of your controller strategy. It depends either in soft or in hard. It will be controller strategy dependent. I mean, it depends of you. Do you allow auto reconstruct or not?
Okay.
In some cases, but I think the default on most of the RAID controllers is reconstruct automatically. Yeah, when you will remove the defective disk and you will reinsert the new one. But according to what kind of storage, I don't know what storage you guys are using. Um, it depends if you are using an appliance, I mean a big storage island with some LSC-based controller, for instance, or if you use an embedded RAID controller inside the server, or it depends. But generally speaking, most of the controllers are set to rebuild automatically upon replacement. But don't take it as a golden rule, and please always check by yourself. Uh, I always repeat it, but it was to say it. Definitely, don't trust what you didn't check by yourself. I would say, at least in this domain.
Okay, thank you.
Part of that, regarding the kind of disk used, this is also a story. Well, you have two disk family, okay, mechanical and SSD. We talked yesterday about SSD advantage. So it's not something we can. There is nothing to say against it. The SSD has a clear advantage in the throughput in I/O. Something it cannot compare at all to what we can expect on mechanical hard disk. The other benefit is is the reliability, clearly. Especially now, the very first SSD was not so much endurance. But now the disks are really very reliable, and what we call the MTBF, the mean time before failure, is much more higher. That's the advantage of SSD from far. Another advantage of the SSD compared to mechanical hard disk, it is that you have a lot of more chance to recover your data on an SSD than on a hard disk, because there is no mechanical part. And what can happen to an SSD is basically two things. You can burn the controller, what controls and orchestrates the read and write to the flash matrix. So the big matrix when you put your binary data organized. Yes.
Please, there is a question.
Okay.
Then after we have to go for a break. It's past 10:30.
Oh, you want to go to break? Okay, all right, fine. Okay, so what's the time?
Okay.
Let me check.
Yeah, but
it's already 11:30. Okay.
So the question comes now.
Okay, go ahead, please.
Okay, thank you. I think you show two kind of storage RAID system. We have the RAID 1 and the RAID 5. We have a possibility to calculate or to have again the data that we lost if one of the RAID had failed. It doesn't mean that we don't need to make again the data backup.
No, not at all. RAID is not a backup, definitely not. RAID protects you only against physical failure. It will never replace a backup. It means, okay, if I do a rm minus rf slash star, okay, I will destroy as root. I will destroy the whole file system, right? If I do that on a RAID, there's no problem. Both, if you are mirrored or whatever, red 1 or red 5, yeah, the file system will be trashed synchronously on all red members.
Okay.
So it is not meant to protect you against any human errors. It protects only against hardware failure, and that's it. If you have a mirror, for instance, a red one, if you will look here, if you are deleting data here, it will be deleted here in real time. If you have a corruption, a file system corruption, I mean, here you will get the same file system corruption here. If your user do an rm minus rf on its home directory, for instance, it will be in real time deleted from both members, and there is nothing you can do against it. So red is not to be seen as a backup replacement. No, never. It just makes your disk redundant. That's it. And it permits to go beyond the physical limits of a single hard disk. The physical limits in terms of capacity, and in terms of throughput, and in terms of input-output of I/O, of IOPS. This is what RAID can provide you. And big RAID array can provide very big storage and incredible bandwidth. This is basically what Ceph and Lustre are doing, but they do it in a very efficient way. It must be seen as a gigantic array spawn distributed over different hosts. So this is how you can basically see this storage. Okay, ladies and gentlemen, I hope.
Yeah, thank you very much, Camille. So we will have 15 minutes break. 15 minutes.
Okay. Just let me check how we arrange the. Okay, I can check that. So 15 minutes, you say, Tarek. Well, I suggest that after this break, we go back to hardware a bit on servers, just to make sure that everything is really clear for you guys. And I suggest that yes, after that we finish with hardware, and then we go for lunch. So it let me some time to prepare the next diagram, because what we'll have to see later, if I don't make a few diagrams, it will be a bit hard to catch for you.
Okay.
So if it's soon as a plan for you, we can do this way. If not, we can arrange in another way. But I think it would really worth, despite of the short time we remain, it would really worth at least that I do a short on network, on storage, but not RAID and so on, not hardware related, on storage, other storage considerations. Yes, I said network, virtualization, storage, and at least this. So we'll try to be the most exhaustive as possible. The idea is to make you ready for tomorrow and after tomorrow, when you on Friday, when you will start with Benoit, because there will be a lot to see, a lot of things, a lot of practicing. It will be very interesting for you guys. I would have loved to be with you for this practice, but unfortunately, it was already very hard to free myself for 2 days. So I cannot do further, and but it is the best effort, as you can see.
Okay.
Okay, so we see after the break in 15 minutes, and after that we go gently to the lunch break, and we start over at 2 p.m. Local time.
Thank you very
Right?
much. Yes.
Okay,
Thanks.
talk to you later.
Yeah, see you later.
Okay.
Hello, everyone. Please